We hope you're enjoying the webinars so far this morning. We will just give it a minute there and let people into the room. As I said, I hope you've enjoyed some of the webinars we've had so far. We still have a number of sessions going on this afternoon, and you are more than welcome to attend those webinar sessions. You can still register for them, so feel free to do that. We have some really interesting panel discussions and then some more speakers in the afternoon. So you are more than welcome, as I said, to join or register for those. We are recording everything also. So we would hope to have this on our website in the forthcoming days and weeks as well, when we get a chance to do that. So you're all very welcome. So I think we'll kick off. I'm just going to give a quick introduction to everyone. So my name is Ruth Clinton. I'm Industry and Engagement and Partnership Manager here at E3, and I'm really delighted to open this session this morning. The session is Decarbonising the Irish Freight Sector, a Microscopic Approach, with Professor Bidisha Ghosh, who is based in our very own School of Engineering here at Trinity College Dublin. Bidisha is leading the Quant Group in the School of Engineering and is an expert in data-driven decision-making in transportation and energy systems. She has published over 175 peer-reviewed conference and journal papers, and her research has extensively been used in cycling and other sustainable transport-related policy documents by the World Health Organization and the British government, illustrating global impact for her research. Bidisha has been an investigator in research projects in the fields of traffic and transportation modelling, environmental modelling, and infrastructure management. She was the chair of the Irish Research Network, the Irish Transport Research Network, an academic member of the Road Freight Forum at the Department of Transport, and she's currently leading the transport strand of Next Generation Energy Systems Programme funded by Research Ireland. So without further ado, I open the floor to Professor Bidisha Ghosh. Welcome.
Hi, Ruth. Can you all hear me? Can you hear me well?
Yes.
Okay.
Yep.
Thanks, Ruth, for the presentation, for introducing me. And I'll probably not spend any further time describing what I do and show you some of the results of what we have been working on in the past 6 years. So in this talk, I'm going to give you some insights from the 3 freight-related projects that we have worked on in the last 6 years. And these projects were funded by several government organizations, such as Department of Transport, EPA, SEAI, and these are the main projects, if I may say so, in the freight modeling in the country and over the last 6 years, I would say. And we are looking to have more projects in this area in future. What I'm going to present today is some excerpts of these projects and not all of it because they're quite big projects. The excerpts will be focused primarily on microscopic approach. Now, first I will start giving you a background into why freight is relevant to supply chain and decarbonization and sustainability. Eventually, we will arrive at the microscopic element of it. So, you know, stay till the end. And here we start with the background. The transportation sector, as you know, contributes almost 1/5 of the total emissions in Ireland, and that's the figure from 2023. Now, road freight transport plays a substantial role, and in 2021, we saw the heavy-duty trucks, which are essentially trucks weighing more than 3.5 tons, were contributing 18% of the total transport emission, whereas light goods vehicle, which are between 2 and 5 tons, were contributing around 13% to this emission. So overall, they made up 30% of the total transport emission. And this sector is supposed to grow even further as the economy grows. So freight is a sector which is very closely linked with the economy of the country. What we see in this sector is a slow uptake of alternative fuel and battery electric vehicles. And this is not only in Ireland, but across the EU, and primarily because there is little availability of vehicles like BEV or plug-in hybrid type of vehicles in the truck sector. Very few models are available in the market, so the market penetration is low. And alternative fuels often are difficult to adapt. However, we are seeing in the Commission and also in which I mean, by that I mean all over Europe and also in Ireland, some uptake of biofuel and biodiesel. One of the key things that we noticed in Ireland, and which was a driving force again for some of the research we carried out, is that Ireland showed a higher fuel consumption or average fuel consumption in freight sector compared to the rest of EU. So this brings us to our first project, what we started looking at when we started looking at freight. Obviously, the project started with mitigation measures. What are the available measures that are there right now in the world, and how these mitigation measures can be adopted in the Irish heavy-duty vehicles. So from now on, I will keep using the word HDV rather than HGV or heavy-duty vehicles. The key research objectives for this project was estimation and projection of vehicular emission, evaluation of possible pollution mitigation method, and looking into the perception of hauliers, who are the key players, the freight owners. In this particular element or objective, the work was carried out together with ECOHDV project. So MAPHDV was funded by Sustainable Energy Authority Ireland and Department of Transport, where ECOHDV was funded by Department of Transport and Environmental Protection Agency. This is a brief presentation of the state of the industry. The data is taken primarily from CSO. You can look into the other data that they collect, which is tonnage, which is vehicle kilometers on their own. What we see is in terms of ton kilometers here, we did see a dip during the recession years. And since the economy has improved, we have seen an increase in the ton kilometers or the amount of activity in the freight sector. And here we can see as well on the right-hand side, the projected values are very high for 2050. If we continue with this kind of climate, we expect that the growth in the freight sector will be quite high. Here, I just want to mention one point is that this project started in 2019. So a lot of the figures that you're going to see are 2018 figures, which was essentially based on the availability of data. But in the later projects, we will present some newer information. So this is the 2018 HDV fleet, as you can see. And this was the time we did see from 2015 onwards the Euro 6 vehicles, which is the present class of Euro class of vehicles. So for the uninitiated, the Euro class is the emission class. So how much a vehicle will emit, based on that, a class is decided. And the decision, these classes were introduced in Europe since 2000. So the initial classes were Euro 2, and then we had Euro 3. And this is also connected to the year of registration or the year in which the vehicle was introduced. So we do see that from 2015 onwards, the vehicles that were introduced are falling into Euro 6 classes. Now, Euro 6 also has a set of different emission classes within it, which indicates their potential of reduction or potential of essentially polluting the air. Here we are looking at it, all of them together as Euro 6, and the distinction is between based on weights, which is one of the key indicators or dictators of fuel consumption and carbon dioxide emission. What we can see is that even though we assume online delivery is one of the biggest way the freight movement happens in Ireland, but we do see in reality the case is a little bit different. And in 2018, it was construction goods. And eventually we see in later years, like right now at present, it is foodstuff and agricultural products which have the largest contribution in terms of delivery of goods or freight movement. The next thing we need to think about is, once we know about the state of the art of freight, how do we estimate how much they're polluting the environment, or what are the decarbonization potential even. So in this starting point, first thing to remember is that emission cannot be measured. This is something that we have to estimate using software. And computer program to calculate emissions from road transport, which is in short COPERT, is the software that is recommended by the European Commission. This is the standard software to measure or to estimate emissions from road sector. It is heavily dependent on data. And in our case, we encountered some challenges because we didn't have the Euroclass data, which dictates the emission coming out of a truck. We only had year of registration, and based on that, we decided on the Euroclass, but some of the Euroclasses were introduced in the middle of the year. Also, the way COPERT calculates emission couldn't be followed directly because the weight categorization with which the data is recorded in Ireland is different from what COPERT uses. So these were some of our challenges, and after dealing with them in some way, we came up with these numbers. As you can see, what in 2018, the Euro 5 and Euro 4 vehicles were the dominant ones in terms of NOx pollution, and in terms of CO2 pollution, we do see Euro 6. Just one thing to note here, it was 100% diesel vehicle. All the trucks were diesel at this stage. Now, the projected emission levels between 2018 and 2015, we do see the number of trucks increasing almost to double. The emission levels is expected to increase significantly. This is assuming the fleet composition to be business as usual. And so far, we are still in the stage that we have very little penetration of electric vehicles or alternative fuels. So we are still continuing with a very heavy percentage or high percentage of diesel trucks. The mitigation measures that we looked at were alternative fuels, alternative technologies, eco-driving, loading, etc. These were the measures that we identified. That was the first stage for the MAPHDV project. We looked into alternative after treatment technologies, and we looked into cost benefit analysis of retrofitting existing vehicles to make sure that they pollute less. In this case, we figured out that SCR technology is only effective in Euro 6 trucks, otherwise it's exceptionally expensive. So these kind of things are essential to really motivate the sector or the hauliers. One of the things we carried out first time in this country with MAPHDV and ECOHDV project is dealing with the freight owners or the freight forwarders or hauliers, and we worked with IRHA, and we carried out in-person interviews with the haulage companies, and we tried to figure out what are their thoughts on decarbonizations, what is the state of the art in their own companies or agencies, and what kind of incentives they use, and so on. These are some results of the perceptions, and we also surveyed the stakeholders, and now you can see side by side the results presented, that what the hauliers think and what the stakeholders think, and based on that, some of the policy will be taken up by the stakeholders. So by the hauliers. The stakeholders will propose the policies, but the uptake of these policies are dependent on the perception of the hauliers. And we do see upgrading of the fleet was one of the key points that the hauliers were very much interested, but they were not thinking about going into electric vehicles. Actually, electric vehicles, like they were not properly even available on the market. However, the stakeholders were pushing that, and hauliers were looking for upgrading into newer Euro 6 vehicles. So these are some of the gaps in the perception. The other thing that we noticed in this project is the lack of data. So there were data, some of the data that was available that we got through CSO, ACAI, and EPA, and other data was not available, like laden weight, Euro classes, like distinction of Euro classes, 6A, B, C, D, where 6D is significantly superior than 6A. So these classes would really help to understand the true picture, detailed about vehicle retrofitting, what are the busiest routes that are used by HDVs, origin destination matrices, and number of professional drivers and eco-driving training. And the most amazing thing about these projects were that a lot of this work that was carried out was taken up in policy implementation very quickly through the Road Freight Forum or the Department of Transport, which I think is a major success for the project. The next project that we worked on was ECOHDV. In this one, we were particularly focusing on eco-driving potentials of Irish HDV vehicles. And in this, we looked at many different things. I'm going to only focus on aspects which are related to individual vehicles, smaller areas, roadway characteristics, and so on. So we start with the VISIM simulation, and this is used to model real-world traffic condition. It is a well-known microscopic simulation tool where movement of individual vehicles are modeled through road sections which are taken from either GIS or GPS data or Google Earth or that kind of detailed road work. And these are we modeled the port area in VISIM and tried to figure out things like fuel consumption, emissions, and travel time. And this is a very well-used tool in Ireland, like when we modeled Lewis, what is the impact of Lewis introduction, or that was modeled using VISIM as well. So we can, so there was a video, if just for sake of time, I will move on to the next part. We also did some work on GLEC, which is fuel economy benchmarking, to get a sense of where we are in relation to fuel consumption in this sector. So with the haulier companies, we surveyed a number, like 12 haulier companies who helped us to get their data. And we looked at the min and max fuel consumption in liters per 100 kilometer. And you can see the mean fuel consumption. And then, as I mentioned, is that we do see a significantly high consumption in certain sectors where you can assume 30 is what is the EU average for fuel consumption, whereas we do see that in some cases in timber haulage, we have seen 48.86. Now, this is not the norm, obviously, but the main profit margin for hauliers is fuel. So this is quite a problematic situation. And then the next thing we did was using telematics and analytics for simulation. In this case, we used a tool called VBox, which is very popular in collecting naturalistic driving data, especially for trucks. So we attach this instrument to a truck, and the truck driver goes around the country, and we measure speed, distance, GPS location, and acceleration and torque and things like that. And this is what we did. We collected significant amount of driver performance data, and we processed the data to get some sense on their acceleration, deceleration behavior, and so on. With this, we came up with an incentivizing scheme for drivers. And we used the telematics data from the timber haulage company, and using that, we came up using an academic method, like a statistical method, essentially. We came up with a tool with which the companies can incentivize their drivers for improving their fuel consumption. And this paper was published in Transportation Research Part D. So this is some further detail of the simulation model development and how we looked at the effect of eco-driving. And in this case, as you can see, we have seen in the port tunnel area, the width, so this percentage that we can see here is penetration of eco-driving, and we look at the effect of impact of eco-driving and on average speed, on fuel consumption and CO emission and so on. And this is what happens during evening peak hour, morning peak hour. And we got some interesting outputs from this. Eco-driving helped us to reduce fuel consumption, helps us to reduce fuel consumption. And we figured out if there are HDV priority signals that are introduced in intersections where particularly we see heavier freight activity, we will see a reduction in CO2 emission. Similarly, if we have barrier-free tolling throughout the areas where freight movement happens, we will see a significant reduction. And also we saw the use of eco-driving training program, the data that we measured from naturalistic driving measured with the telematics or VBox, we did see the effect of eco-driving in the simulation. Now, this brings us to our most recent project, which we only finished last year, which is decarbonization of Irish heavy-duty vehicles. And again, in this project, I'm only going to focus on the microscopic part of it. And I'll just go here quickly. So here we were looking again in more detail on the using COPERT, understanding how the NOx and CO2 emissions happen in urban, rural, and highway situations. One of the issues that we noticed with COPERT is that it doesn't take care of cold start data, and it has some other limitations, like total emissions from pollutants like CO2, NO, and SO2 were not fully presented because of the missing cold start data. These are our figures. As you can see, urban is one of the major, urban off-peak and urban peak is the major areas where we see significant energy consumption. And by energy consumption, it is a surrogate or a proxy for emissions, NOx and PM emissions. So the more fuel is consumed, more pollution is emitted to the environment. Then we moved on from the COPERT to even further detailed approach. And in this case, probably it's worth spending a few seconds, or considering we have very little time, on this particular approach, microscopic approach. Microscopic approach is looking into individual vehicles. So the study of traffic can be divided into two paradigms. One is looking into vehicles as aggregate, bringing all of them together. And the other is looking into vehicles as individuals, looking into individual driver behavior, individual vehicle characteristics. So there is another tool developed by the European Commission called VECTO, which is Vehicle Energy Consumption Calculation Tool, which can be used for freight sector for calculating the emission coming out of individual vehicles, considering all its engine characteristics, its maintenance, and so on. And this was what we were looking at. In this level, we decided that rather than using the European drive cycle, which is essentially what we use for testing vehicles for their emission standards, to use something like Irish specific cycle. So the first step was developing the cycle. We again went back to our data set, which we collected between January and March 2020 on these routes. And what we did is we processed this data to develop a drive cycle, essentially how people drive in Ireland. So we divided the data set into freeway, regional, and urban, and we developed the drive cycles. And this is what we see, how it is distinct from the European driving behavior. And what you can see, the blue lines are, blue and the red lines are the drive cycles for urban situation. And Vecto is the red one, and blue is the Irish one. And we again see the same for regional driving and freeway or highway driving. And we worked with existing engine specifications to develop our full emission results. In this, we can figure out what percentage of time individual vehicles spent in different gears, fuel consumption, CO2, simulated versus observed fuel consumption, and so on. And these are our results. As you can see in the Irish drive cycle, we do see in urban setup, there is difference with the vector drive cycle, which is represented with the brown bar, but there is no significant differences in regional and freeway. So the main high fuel consumption we see in Irish roads is actually happening in the urban areas, and some measures of reducing that will really help. Apart from that, we looked into the effects of things that we identified in MAPHDV project, like a possible reduction in fuel consumption by reducing idling. There is around 4% reduction in fuel consumption, then possible reduction in fuel consumption by change the effect of road gradient. So going on roads with lower gradient variation will definitely improve the fuel consumption. And all this has again been published in a paper on Transport Research Part D. And eventually in this project, as I said, I will not present anything macroscopic, but we looked into a set of different vehicle types, and this in different scenarios, and look into what are their potentials of CO2 emissions and adoption in the industry. And this research was published in Nature Scientific. And if you're interested, all this is going to be published on the website. And the main recommendation from these projects is from the DRIFTHDV project is that it is important to develop drive cycles for Irish conditions. Idling and gradient has some significant effect, and influence of zero emission BEV trucks is important, but cargo capacity and recharging time affect them. And eventually concluding the presentation, sorry, I'm rushing a little bit, but just the key things from these three projects is that we want to see significant increase in data collection. And I know from personal experience that Road Freight Forum and Department of Transport is looking into it. Looking into transitional and softer measures such as eco-driving, barrier-free tolling after treatment can help in some reduction in emission. We cannot reach our targets fully with those, but it can help in the transition. We need further research done to develop policy and create evidence base to understand how these will impact, or how can we reach our net zero future. And it is very important to support the hauliers who are crucial in actually achieving these targets by uptaking the policies. And yeah, that brings me to the end of the presentation. Thank you.
Bidisha, thank you very much. That was really, really insightful and a lot of research. And I think it's really amazing to see the direct impact that your research can have on policy in terms of all of the outputs from the projects that you're doing. I think we have time for one question, and we have one question here. So I might just read it out and see if you can answer it. So somebody, Harris says here, given that many mitigation strategies, such as alternative fuels and eco-driving technologies, are data-driven and often implemented in developed countries, how can least developed countries balance the high cost of ESG investments with the need to reduce emissions and achieve sustainable development, particularly when such options are not yet feasible or prioritised?
So specifically, thank you very much, Harris, for the question. So specifically, you mentioned eco-driving, and this is one measure which does not require any data-driven approach. This is a measure that is more a training-based measure, and continuous professional development of the drivers and driver training is the key. So if you read our ECOHDV project report, it'll give you a lot more insight into what we are recommending. In our study, we essentially gave the drivers some directions with a piece of, like a quick start guide, what to do for eco driving. And they looked at it, and then they drove their trucks, and we noticed a change in their harsh braking, harsh acceleration behavior, cruising behavior. So eco driving is a measure which is not technology driven per se, and can be adopted very easily. A lot of these transition measures are softer measures which are not heavily affected by the cost. Whereas for other measures, I think it is for the developing countries, it's more or less wait and watch, because we are expecting not a huge, but some trucks like BEV and hydrogen trucks to come in the market. By hydrogen, I mean fuel cell. And once they are in the market, just like electric vehicles, the prices are supposed to drop if they are taken up, and then maybe that can be the next step. But in the meantime, reduction of emission by 5 to 10% is not something that we can ignore. Why don't we try to achieve that?
Okay, great. And Bashida, I have one question as well. Just going back to the first project, the MAPHDV one, and the stakeholder and haulage interviews that you did was really interesting. What were the biggest gaps there between the two stakeholders and the haulage? I know you spoke about it briefly, but just some insights into that, because I think that was really interesting in terms of the gaps.
It was really one of the key things that we noticed, and it's still continuing, that the stakeholders are more focused with the long-term effect, which we do expect to see from the public and kind of policy developers and public authorities, whereas the hauliers are focused into their short-term goals, which is
Yes.
essential to survive in the business.
Yes.
They
Yes.
will not be able to run for 10 years if the business does not make
Yes.
profit in this year. And this
Yeah.
is really the gap. So stakeholders
Mm-hmm.
are coming up with solutions like buy BEV or CNG trucks, where
Yes.
hauliers are saying they're very expensive. We can't really invest the money. So things
Yeah.
like that. But the overall picture is the long term and the short term, and
Yeah. And
things available in the market.
yeah, and you can understand the policymakers need to have that long-term vision implemented, but yeah, the businesses need to be able to survive year to year, especially in the kind of political landscape at the moment. So yeah, it's interesting to see how these two can come together. But look, that was a fascinating discussion, Bidisha. I really appreciate your time here today. So what I'd really like to thank you for your time and thank you for the presentation. Once again, we'll have these presentations on our website, and if there's any papers that you'd like to look at, if any of our participants would like to look at, please go onto our website and we'll have them there as well. So thank you for that.